All right, welcome everybody to the video for 11.4 Part D, adding and subtracting fractions. So today what's going to be different is we're going to be looking at the denominators also being binomials. Okay, they're different binomials. In other words, we don't have like terms. So a little bit of review before we hit that piece. Long division. So when we're dividing by something that's not a monomial, so it will usually just be a binomial in this chapter. What we have to do is set that up as a long division problem. So we put what we're dividing by out front, okay, what we are dividing underneath, and we start to try to cancel out front terms. So the first thing we need to do is take this x and multiply it by something so that it cancels out the 2x squared. To do that, we need to multiply by a 2 up there, okay, and another x, because 2x times x is 2x squared. So remember what we're doing with this 2x, we're multiplying it by the x, but we also have to multiply it by the negative 1. So that would be minus 2x. What we need to do in that step is subtract. So we need to subtract here. And one thing we said that might be a little bit easier is to distribute that negative sign. So we add the opposites. We can turn that to a plus, a negative 2x squared, and a positive 2x here. All right, then these two should cancel. If they don't cancel, then we did something wrong. Now we have 5x and positive 2x to make 7x, and we bring down the next term, which is a negative 10. Then we start over. So now I need to multiply this x by something to cancel out this 7x, and that would be a positive 7. 7 times x is going to give you 7x, and 7 times negative 1 is going to give you that negative 7. Okay, same exact situation. We need to subtract, which means add the opposites, negative 7x and positive 7. These two will cancel. We have negative 10 plus 7, giving us negative 3. That's our remainder since there's nothing else to bring down. So where we put that is right up with the answer, a minus sign, since our remainder is negative, 3 over x minus 1. And that's going to be our answer. Okay, so long division to start off the notes today, something that we don't want to forget before test time. So with long division, hey, then we moved into the add subtract part of the chapter. All right, and here's all the different ways that it has worked out so far. So sometimes the denominators were already the same in both, like we have in both of these. So for this one, since the denominators already match, we can add the tops. I'm leaving the 4x on the bottom because when you add fractions, you don't change the denominator. So we have 2x and 6. I'm not combining those into an 8x because these are not like terms in this situation. So then, if we can add the tops, then we can look at taking out a common factor and then reducing where we can. And what we can do for this one is we can divide 2/4 and turn that into 1/2. So what we have as an answer, I'm not going to write the 1 up top again, but we have an x plus 3. We have a 2x on the bottom. So we add across the top and then we reduce. That's if the denominators already match, like they do in this one. So I'm going to copy the bottom down exactly the way that it was. X squared minus 5x minus 24. And then again, it's the exact same two numerators. So 2x and 6, it's still not 8x, just like in the last problem. But then we can start to factor. So we can take a 2 out of the top, just like we did in the first problem. Same exact situation. But the bottom now is a trinomial, so we can try 2 parenthesis factoring. So what we need to use is a positive sign and a negative sign, since the last number is 24. And then we want to try to find some numbers that multiply to 24 that are 5 apart. And that would be 3 and 8. And we want to try to make the bigger number negative so that our 5 ends up being negative. 3 times negative 8 is negative 24. 3 minus 8 is negative 5. Then we can cross out the matches. That would be our x plus 3's this time. And what we did not cross off is our answer. That was the first type of adding and subtracting. The denominators already matched. Moving into the next type where they didn't match, we're looking at, there we go. If they didn't match, it could have been monomials like this one on the left. So in that situation, we need to find that lowest common denominator. We look at numbers first. So between 5 and 2, the smallest common denominator would be 10. And then we have x to the second and x to the third. We take whatever that bigger exponent is for that lowest common denominator. So we can always give a fraction more x's. It's hard to take x's away. So we would give the left-hand fraction another x. So the way that will work, we need to multiply the left-hand fraction by 2 so that we get our 10. But this is the fraction that also needs another x because we need a total of x to the 3 for both of them. So whatever you do to the bottom, you're going to do to the top. So we end up with a 6x over 10x squared for that first fraction. Okay, and then this one already has the correct amount of x's, but it needs to get multiplied by 5. When you do that, you need to distribute this 5. So we get 5x plus 20 over 10x squared. And then we can look at adding those together for our final answer. It will be our final answer because we won't be able to reduce. So what we have here are some like terms. The 6x can combine with the 5x and make 11x. Then there was a positive 20 on the top that doesn't combine with anything, and a 10x squared that doesn't change on the bottom when you add fractions. Since 11x and 20 don't have a common factor, that is our final step for that problem. Same thing starting this one. Okay, this was yesterday's assignment. Okay, when there's at least one binomial in the bottom. So what happens with that is we took the first denominator and the second denominator and we just smushed them together. So it's the product of the two denominators as soon as there's any kind of plus sign or minus sign in the bottom. So to work that one out, we need to multiply each fraction by the other denominator. So this one needs to get multiplied by x minus 5 or x plus 5s. This one needs to get multiplied by x over x. Okay, so this on the left-hand fraction, we're going to distribute. We have a 2x and a positive 10 over x plus 5 minus problem this time. We have 3 times x over x times x plus 5. And again, it's usually just one more step. So the like terms this time are the 2x and the negative 3x. Those add to negative 1x, or just a negative x. Then we have a positive 10 in the top, and we have x plus 5 in the bottom. So that's all the types of adding we've done so far. Now what we need to be able to do is the last version of this, which is both denominators being binomials. Okay, it's not that different than what we did yesterday. We can use the exact same strategy as before, okay, and just multiply the two denominators together and get that LCD. So the lowest common denominator for this first one, okay, is just x plus 3 with an x plus 4 after it. So what we need to do is just multiply by the other denominator. So this one is missing an x plus 4, while the second fraction is missing an x plus 3. Okay, so then we can distribute. So we have 2x plus 8 in that first one over x plus 3 times x plus 4 plus, do the same thing over here, 3x plus 9 over x plus 3, x plus 4. Now it's just about combining like terms. So the first pair of like terms, again, I'm gonna leave the denominators the exact same. Now I'm in the adding step. Now I'm just trying to combine the like terms up top. One pair of like terms is a 2x and a positive 3x, so we have 5x's from those two. The other pair of like terms is a positive 8 and a positive 9, which gives us positive 17. since 5x and 17 don't have a common factor, there's nothing I need to do to reduce this at all. Notice how I have two binomials on the bottom. I'm not foiling them. I'm purposely not foiling them. I'm not trying to expand them or anything like that. So, second problem, the two denominators are x minus 1 and x plus 2. So we're just gonna put those together. We're gonna multiply each one by the other one's denominator and try to get an answer from there. So this one needs to get multiplied by x plus 2 over x plus 2. Okay, that means we're going to distribute that 4 in a second. This one needs to get multiplied by x minus 1s. We're going to be really careful with with that negative sign too. So we have 4x plus 8 over x minus 1 times x plus 2 minus sign. We have to distribute this one, 3x minus 3 over x minus 1 times x plus 2. Okay, now the bottoms match. Before we look at maybe combining those like terms, one thing that might be smart is to flip those signs. We need to make sure that we're subtracting that entire group. So we can add the opposites just like we did in long division at the beginning of all this. So we can change this into a negative 3x and this into a positive 3. Then we can look at getting into that adding step. X minus 1, x plus 2. Okay, now we can start to combine like terms. So we have a 4x and a negative 3x. Those will add to 1x. We have a positive 8 and a positive 3. That will add to positive 11, and that would be our answer. So when there's two binomials, that's the way that that's going to have to change. Okay, we're going to just use that as our lowest common denominator. Take the two denominators and put them next to each other. Okay. All right, and then going forward with that, okay, looking at this next one, I'm going to skip right to this last one, actually. Just looking at the one in front of us, that one looks a lot the same. This one's more of a challenge problem then. So the LCD here, x minus 5 and x plus 3. Okay, so this one needs to get multiplied by x plus 3. This one needs to get multiplied by x minus 5. This is a little bit tricky here. Right here, the way that I have to multiply that is with FOIL. I have to FOIL that out up top. So I have to take x times x, which is going to be x squared. I have to take x times 1, which is 1x. I have to take 3 times x, which is 3x. And I have to take 3 times 1, which is 3. Then on the bottom, I have my common denominator. Plus sign this time. This one's just distributive. So we have x squared minus 5x over that same stuff. So the tricky thing with that one was just having to FOIL. Okay, and then we can combine those like terms. So now we're in that final answer stage. So if we could get the x squared and the other x squared added together, that would be 2x squared. And then we can do positive 1x and positive 3x, that's 4x, and negative 5x, that all adds to a negative 1x. And then we have a positive 3 all by itself there. And that would be over x minus 5 times x plus 3. All right. And then there's not going to be a way to factor that trinomial on the top, two minus signs multiplying to positive 3 but adding to negative 1. So that's it. That's our video. Thanks for watching.